below that line. If you get those both right.
Okay, now reasoning other than the less than sign, because that doesn't always give it to you 100% sure. If we looked at it, I did see some of you doing this, if you actually looked at the line as in slope-intercept form, it would cross the y-axis at 2, because that's its b. And then from there, the slope, it's negative x, so it's negative 1, so you would go down 1 and over 1. So the line would look like that. So you can test 0, 0 on that. So I would say 0 is less than or equal to 0 plus 2. Yes, 0 is less than or equal to 2. So that's part of the solution. So that gets shaded. So it is still below the line on that. All right, solving systems of equations. Alright, I got two equations to start with. This is 2x plus y equals negative 6, and then x plus 3y equals 2. So the question we're going to start off with, the question we're going to start off with says, is the point negative 4, 2 a solution to that system? Okay, so just a reminder of some Algebra 2 stuff. When we're finding solutions to the system of equations, that is actually where the two lines would intersect. So we're trying to find out, would those two lines intersect on that point? And we have done this before in Algebra 2. The three ways, and actually Algebra 1 also, the three ways that we cover to figure out the solution, we can do it by graphing, which is the least accurate. I don't like that one as much. I don't do that very often. Substitution. When things are ready for substitution, I do that, or elimination. Elimination seems to always be everybody's favorite, but sometimes they're not ready for elimination yet. But this time I don't have to find an actual point. I gave you one, and I'm asking you, is it a solution or not? So to check and see if that's a solution, since this is an x and a y, I'm just going to plug them into the x and the y, and it's going to make both of these equations true. Okay, what does that mean? Let's plug it in and see. In that first equation, I would have 2 times negative 4 plus 2 equals negative 6. I put the negative 4 in the x spot and the 2 in the y spot. Okay, so that's negative 8 plus 2 equals negative 6. Negative 8 plus 2 equals negative 6. So that would be true, right? So it worked in the first equation. It's going to also make the second equation true. Okay, so we would say negative 4, I put negative 4 in the second equation in the x spot, plus 3 times 2, because that's my y, equals 2. Negative 4 plus 6 equals 2. Negative 4 plus 6 is 2. So is this a solution to that equation? Yes. Okay, pretty simple on that. Alright, I am going to, as we're actually solving them, that one was just the warm-up there to get you started. And by the way, when you find a solution, that's how you can check them. You can plug them back in that way. I am going to go through all three of the methods. See if we can figure out which one's easier and all that kind of stuff. So first one we're going to do is going to be by graphing. Alright, my first equation says 2x plus y equals negative 5. My second one says negative x plus 3y equals 6. After I show you this by graphing, I'll probably never do another one by graphing. Just because it's not as accurate, especially if you get fractions of your answer's a fraction, because it's hard for us to split those spaces up equally into fractions and all that kind of stuff. But for now, I'll show you that and you can get your idea. Alright, they're both in standard form. So we graph a line when it's in standard form. We can plug zeros in and get intercepts, or we can solve them for y and put them in slope-intercept form. So what do we want to do here? Solve for y is what else I said. So on number 1 here, I'll just subtract 2x. So that give me y equals negative 2x minus 5. Alright, so that means that line is going to cross the y-axis at negative 5. 1, 2, 3. Let's scroll a little bit more. 1, 1, 2, 3, 4, 5. Get on that point, there we go. Then its slope is -2. Since I'm out of room going down, I'm going to go up 2 and left 1. I did my negative to the left. Is that all right with y'all? Thank you. So that line would look something like that. Okay? Everybody all right? Now the other line, if I solve this one for y, I'm going to add x, so I'd have 3y equals x plus 6. Then I'd have to divide everything by 3, so y would be 1/3 x plus 2. Okay? So its y-intercept is 2, so I'm going to go up to 2. And then from there, its slope is rise 1, run 3. Rise 1, run 3. Since I'm looking for where these intersect, I want to bring it this way also. So I'm going to go down 1 and left 3. Well, right there, they're fixing to hit. Let me draw that. Now our answer that we just found is the name of that point where they intersect. So to get there from the origin, I would go left 1, 2, 3. So I got a -3, and then I went up 1. So -3, 1 would be the solution. Now if I didn't have graph paper, if I didn't have a magic straight line drawer, that might be difficult for me to get. That's why I don't like graphing as much. Alright, good on graphing? Do it. Alright, this one says 5x minus 3y equals -6, and then x equals 2 minus y. Alright, directions say solve the system, so we're looking for where those two lines are going to intersect. Now the method we're fixing to use on this one is what is called substitution. Substitution out of all three of the methods would be the easiest one on this one. Substitution is easiest to do if you've already got a variable solved for. On this equation, the second one here, it says x equals. So the x is already solved for on this case. That's when I'll do substitution, when I look at two of them and I see that one of them already has a letter solved for it. If it says x equals or y equals, it's already solved, it's ready for substitution. Because if x is this, and isn't that what that equation says? X is that. So I can take what x is and I can substitute it in for the other x. Right? So I'm going to have 5, but instead of x, I'm going to put what x is. Times 2 minus y. And then just bring the rest of it down like it was. Minus 3y equals -6. Okay, now what would we do to start simplifying that? Distribute that 5, so it gets me 10 minus 5y minus 3y equals -6. I got some like terms there, don't I? So when I combine those y's there, that's 10 minus 8y equals -6. We got a two-step middle school equation to solve now. Need to get the y all by itself. Subtract the 10. Gets me -8y is -16. Divide by -8. And y is 2. Now remember, we're trying to find the ordered pair where they intersect. We know the y. So what am I going to do to find the x? Good, I'm going to take that 2 and go plug it back in for one of the y's. Either you can plug it in either one of these. I can tell you right now, this one would be the easiest, right? Because that one says x equals 2 minus 2, because 2 minus y, my y is 2. So x would be 0. So there's the solution to that one. Y'all remember doing that? Yeah. Should. Really?
It's so long.
The elimination ones, when we get into 3, they get really long then. It's when it takes like a page of paper to do one.
And when I first taught it, it was that crazy old man. Like he knew what he was talking about, but like he didn't know how to share it.
Yeah.
So he was just like bouncing all around the room talking about it. We were like,
running into a wall or
Yeah,
something.
my geometry teacher. She was special.
Was she like messed up?
No, she was trying to show us what a plane was, so she hurled herself on the wall and screamed, "This is a plane." And then she started walking around the room grabbing points. You see them? They're everywhere. Get away from me.
My mom's teacher did this.
Your desk next to you?
When you did? My mom's teacher.
That is hilarious.
Did she not get fired?
I have no idea. That's back at us.
No, we did it.
Really?
Okay, this one we've got 4x plus y equals 5, and then 2x minus 3y equals 13. Alright, I'm going to do this one with you substitution as well. But if I were doing this on my own, I probably wouldn't. But I want to do one more with you for substitution, so we're going to do this one that way. If I want to substitute it, I need to get one of the variables solved for. I need to isolate one of the variables. So I'm looking to see which variable I can isolate in the fewest amount of steps. Okay, if I wanted to isolate this x, I would have to subtract the y and divide by 4, right? If I wanted to isolate this y, I would just have to subtract the 4x. That would just be one step. If I wanted to isolate this x, I'd have to add the 3y and divide by 2. You following that? If I wanted to isolate this y, I'd have to subtract the 2x and divide by -3. So to get the 1y by itself will be the least amount of work. If you've got something that has a 1 in it, that's always the easiest one to solve for because you don't have that division step. So that 1y there would be the easiest. So I'm going to subtract 4x from both sides. So I'm going to have y equals 5 minus 4x. Now if I was writing that in slope-intercept form, I'd flip that. Slope-intercept form, the mx comes first, but I'm not graphing this, so it doesn't matter. I'm going to just leave it like that. Okay? Now that's what y is, so I'm going to plug that in for the y. Okay, so I'd have 2x minus 3 times 5 minus 4x equals 13. Alright, what would we do now? Distribute. I'm going to distribute that as a -3, so I'll make sure I get all my signs right. So it's going to make minus 15, and then here a negative times a negative is going to be a plus 12x. Okay, yeah, that.
Put the x's
Good, I would do the x's together
Put the x's
first.
together.
So that would give me 14x minus 15 equals 13.
And then add the plus.
Good. Now we're ready to add that 15. So that gets us 14x is 28. So yes sir, x is 2. Alright, so we've got an x, we still need a y, so I've got to have somewhere to plug that 2 back in. Now, I could plug it in, I've got my 2 originals right here, or I can use this new one that I configured there also. It doesn't matter. If I'm trying to find y, this one's solved for y, so that would probably be what I would do. But you can put it in the 2 new ones or the one that we solved for. Anybody got a preference? The one we solved for, so y equals 5 minus 4 times 2. So y will be -3. That's it. Alright, let's look at some elimination now. We've done graphing, we've done substitution. Let's look at elimination. This is my favorite, but they all work. Alright, I've got -2x plus 3y equals -10. And then I've got 2x plus 2y equals 5. Alright, you know eliminate means you're getting rid of something. So you're looking to just put the equations together as they are to be able to eliminate a variable. when elimination is the easiest and when it's ready is when your coefficients on one of your variables are the same. My x right now, they both have a 2. So it's ready for elimination. That's what you're looking at. Okay? So since these both have a 2, I am going to eliminate. So draw my line underneath them like I did when I was a little tot. And all I got to do now is figure out, am I going to be eliminating them by addition or subtraction? There are some teachers that make you use addition every time. I don't care about that. We're in the 12th grade, we can add and subtract both, so we can do it either way. The decider is going to be our signs. If our signs are different, and right now they are, I've got a negative and a positive, you're going to add. Because negative 2 plus 2 is 0. It's whatever it takes to make it a 0. If your signs are the same, if these have both been a positive 2, what would you do to make that a 0? Subtract. So it's based on what the sign is of the letter you're eliminating. So right now my 2x's are different signs, so I'm adding. Negative 2x plus 2x is nothing, he gone. 3y plus 2y is 5y. Negative 10 plus 5 is negative 5. How do I figure out y now? Divide by 5 and y is negative 1. Now you got to plug that back in to figure out an x. Doesn't matter which one. You want the top one or the bottom one? Bottom. I do that too because I like the positive number. 2x plus, I don't know why I did that, 2 times negative 1 equals 5. So 2x minus 2 equals 5. We're going to get a fraction on this one, aren't we? Add your 2. 2x is 7. Divide by 2. X is 7 halves or 3 1/2 or 3.5. I'm going to just leave it as 7 halves. Let's do one now. We're using elimination, but it's not ready yet. We have to do some preliminary work to get it ready. Okay, this one says, maybe if I can get to the next, there we go. 2x plus 3y, bless you, equals 19. And then 3x minus 7y equals negative 6. Alright, so I'm just told to solve the system. Bless you. When you have an assignment or a test where you're told to solve the system, you can do it any way you want. So if you're like, well, I really like substitution, you could do that here. This is not friendly for substitution because, number one, it doesn't have a letter solve for, but you can solve for one of them, but they've all got a coefficient, so it's going to take a couple of steps to solve for one of them. But you could do that. Okay? It's not ready for elimination either, so whichever one you choose, you're going to do some work to get it ready for it. I'm going to do elimination on this one. So I'm looking, my x's, I've got a 2 and a 3. It's not the same. My y's, I got a 3 and a negative 7, or 3 and a 7. It's not the same. So I've got to decide now. I know that 2 and 3, I can make those both be 6's. So I can make my x's both be 6's and eliminate that. 3 and 7, I can make those be 21's. Bless you. So I can make my y's both be 21's and eliminate that. Either one will work. So what do you want to do? Make them 6's. So to make this first x a 6, I had to multiply it by 3, which means I got to multiply that entire equation by 3. Okay, so that gets me 6x plus 9y. Don't forget the equals part also. Equals 47 or 57? 50, 57. 19 times 3 is 57. Okay. Now, what do I need to multiply number 2 here to get a 6x? 2. So that gets me 6x minus 14y equals negative 12. Alright, so now we got 6's. Am I going to eliminate those 6x's with addition or subtraction? Subtraction, very good, because they're both same signs. So to make that be a 0, I have to subtract. Now, don't forget that means you got to subtract on every step. Some people mess their signs up on that. 6x minus 6x is nothing. He gone. 9y minus negative 14y. What's 9 minus negative 14? 23y. 57 minus negative 12. Nope. The boys were right over there.
It's not minus.
You already know.
57 minus negative 12. Okay? So then divide by 23. That's 3, isn't it? Alright, so you've got 4 choices for where you can plug that 3 back into now. Because you can plug it into one of the 2 original ones or one of the ones we multiplied by. I'll never use one of the ones I multiplied by, because if I did that, that made the numbers bigger and that's harder to do in my head. So I always go back to smaller numbers where I plugged it in. You would plug it in the 2x one or the 3x one? 2x one. So 2x plus 3 times 3. Oh, I skipped a step. You alright?
Oh, yeah. Wait, are you looking? Are you talking?
Yeah.
Yeah.
Do you know where I got that 9? Okay. Just checking. What would I do now?
Check that 9.
Did.
X equals 5.
Good job. So don't forget to write it as your ordered pair, because that is a point where the 2 lines would intersect. Woohoo! Alright, everything that we've looked at so far has had one solution. Okay, so that means it's been 2 lines that are going to intersect one time. One solution. We could have lines that are never going to intersect. Well, those will, but you get the point. We could have parallel lines that are never going to intersect. We could have a line and then another one that is the same line that intersects infinite many times. So we got to look at what those special kind of answers will look like, okay? All right, this one says 2x plus y equals 6 and negative 8x minus 4y equals negative 24. Alright, so first thing I'm going to do is give you an option on what do you want to do. We're told to solve the system. This is going to have a special answer. I just hinted that at you. Do you want to solve the system by graphing, substitution, or elimination?
Elimination.
Okay.
It's
You
going to
could-
be infinite.
You could.
Times 4.
Yeah,
both the
because
same.
Yeah.
You could. We might not have got to that over here.
I know.
We could do substitution on the first one easy, but it is elimination also. Now, what Blake noticed already, to make my, I'm multiplying by 4, but that's making them, okay, I don't know what I'm trying to say. 8x plus 4y equals 24, right, when I distributed the 4 to that?
Yeah.
And then negative 8x minus 4y equals negative 24. Okay, all the signs are the opposite, so we're adding. That gets me 0, 0. So this side, I don't have anything left. On the right side, 24 plus negative 24 is also 0. Okay, now it's not always going to end up being 0, 0, but it's going to be a true or a false statement. Okay, this is true. 0 does equal 0. That's true. It could say 1 equals 1. It could say 99 equals 99. A true statement means that there are infinite many solutions, which means it's the same line. And that one was a little obvious, as Sir Gwatney pointed out. Okay, so a true statement on that, infinite many solutions. So that tells you what a no solution is going to have. I just said it on accident.
False.
Thank you. A false statement. Let's look at one of those. That's also called dependence. Remember we talked about that a couple of chapters ago. Dependent. All right. If we have 4x minus 3y equals 8, and 8x minus 6y equals 14. Alright, do you want to do substitution or elimination? Elimination. So to make I can make my x's both be 8s, I can make my y's both be 6s. Either way would take multiplying by 2, right? So let's multiply that top one by 2. Gets me 8x minus 6y. So far that looks just like the bottom. Equals 16. Now it doesn't look like the bottom anymore. Bottom one's got 8x minus 6y equals 14. Alright, my 8x's are same signs, so I'm subtracting. 8x minus 8x is nothing. Negative 6y minus negative 6y. It's also nothing. 16 minus 14 is 2. That's right, I like that. That is not correct. 0 does not equal 2. That is no solution when you get that false statement. Fancy other word is it's inconsistent, as are a lot of us. Alright, I want to go back and give you a normal one to try on your own. If we do alright, we'll be good. Let's do a normal one to try on our own. It's got one solution. It says 2x plus y equals negative 5. I think I might have messed up just a minute. No, I didn't. And then negative x plus 3y equals 6. Okay, that has one solution. See if you can find it. You can use any method you want. Go. Nope.
What are you trying to find the X one?
Mm-hmm.
Not a fraction.
You good?
Thanks, so good.
choose to eliminate?
Yes.
Okay. You didn't? Good. Substitution, good. I'll do it. If y'all didn't get it right, I'll do it substitution also. When eliminators over there, did you eliminate the x's or the y's?
X's.
So you probably multiplied the bottom one by 2 then, right?
Correct.
Okay. So we got 2x plus y equals -5. Just wrote that top one again. -2x plus 6y equals 12. Okay, now what would they have to do, add or subtract? Add. 2x plus -2x is nothing. Y and 6y is 7y. -5 and 12 is 7. So they got a y of 1. That is substitutors. Okay, but that's okay. I'll look at substitution next. Plug that back in. If I'm trying to solve, I'll probably put it in the first one. 2x plus y, so 2x plus 1. Subtract 1. 2x is -6. So x is -3. Good job. Alright, I'm going to do that same one substitution now since we had some substitutors.
Yeah, I got it right.
Good job. I got 2x plus y equals -5. And then I've got -x plus 3y equals 6. Alright, substitutors. Which equation did you isolate a variable in?
2x, yes.
Okay, so you subtracted the 2x. Alright, so you'd have y equals -5 minus 2x. Okay, so if that's what y is, I gotta plug that in the y spot on the other equation. So -x plus 3 times -5 minus 2x equals 6. Alright, on that, Katie, distribute the 3, -x minus 15 minus 6x equals 6.
Yes.
Then you've got like terms there. -x minus 6x is -7x.
Yeah.
Yep. And then what would we do? Good.
Yeah.
Plus -7x equals 21. So x would be -3. Okay? You good? Did you get that one? So then you didn't get it when you plugged those? Or did you have it right? Okay. Alright, now I gotta plug that back in. I would plug it in this one right here where I solved for. Don't you did, Louise? So I have y equals -5 minus 2 times -3. -5 plus 6 is 1.
We forgot to.
Because it wasn't negative.
Alright, not bad on that. Tomorrow's stuff is what Devin's been begging for. There's going to be 3 equations with 3 variables. Devin, control your enthusiasm. You can do it. Okay? So tomorrow we'll look at X, Y, Z. 3 equations with 3 variables.
Let's try to 96.